Okay, so then now we've gone over our parent function. Now we need to talk about doing our shifts on this. We need to talk about doing our shifts. So first thing, we need to remember that the inside is going to cause horizontal changes. Okay, remember anything on the inside is going to make it shift left and right. We do want to remember with our horizontal changes, okay, remember that we do the opposite. We always want to do the opposite when we are dealing with our horizontal changes. Okay, outside is going to cause vertical changes to occur, and you will do what it says for your vertical changes. One other note, negatives will make these things flip. Okay, negatives are going to cause these things to flip. All right, so let's go ahead and get started, horizontal, vertical. So how do I know what's on the inside, what's on the outside? Well, you're going to have y equals anything out in front is going to be considered on that outside. Okay, so anything out in front will be considered on the outside here. Your base, there will be a number in there for your base. Okay, remember that base is only determining your parent function. Okay, the inside is going to be that anything that is actually up in the exponent. The only way you are going to get a horizontal shift is if something is inside the exponent. The only horizontal change will happen is if it is actually up in the exponent. Back behind, out in front will be considered outside, which will cause vertical changes. Okay, so let's graph a couple of these. F of x equals 2 to the negative x minus 3. First off, you're going to have to label these graphs, so get in the habit of go ahead and doing that. Y equals 2 to the x for my parent function. I need to make a table to graph this. X, y, negative 1, 0, and 1. 0 always goes with 1. 1 goes with the base, which is 2. Negative 1 goes with the reciprocal, which would be 1/2. So I'm going to graph my points. 0, 1, 2, 1, negative 1, 1/2. And of course, don't forget your horizontal asymptote. There's my parent function. Okay. I always want to work on the inside. So y equals 2 to the negative x. Now remember, your negatives are going to cause flips. And that's going to flip horizontally. So these points over here are going to be flipping horizontally. So my asymptote won't change, but my points here are going to flip it in that horizontal direction. And then the last thing is this minus 3. Y equals 2 to the negative x minus 3. Well, that minus 3 there, that would be on the outside. So I'm going to do what it says since I'm on the outside, and I'm going to go down 3. So each of my points will move down 3. The other thing that moves down 3 is my asymptote. It will also shift down 3 as well. So there is my first shift for my exponential function. Okay, nothing too crazy. All right, now I've got f of x equals 2 to the x plus 3 minus 1. Okay, parent function, y equals 2 to the x. It's the exact same as the one we had before. Remember, 0 goes with 1, 1 goes with 2, negative 1 goes with 1/2. Okay, so again, 0, 1, 1, 2, negative 1, 1/2. Don't forget my asymptote. Good there. Okay, now this x plus 3, y equals 2 to the x plus 3. Where is that plus 3 at? Well, again, it's in the exponent, so that is on the inside there. That plus 3 is on the inside. So we're going to do the opposite. This is going to shift to the left 3. So my horizontal asymptote does shift to the left 3, but it doesn't really look like it because it's a continuous line. So each of these points will shift to the left 3, though. And they will actually show that it's moving. Okay? And then again, the last one, we've got another minus sign. This is not up in the exponent, so that's a vertical change. So all these points will now move down 1 spot. Like so. Okay? So again, nothing crazy on our shifts. If you guys want to start working ahead and trying some of these on your own, feel free. Okay, we've got 3 left that we're going to do here. Okay, now this one does have a slight trick to it, not a very big one. Okay, but this is something you should be prepared to see on your test. I've got f of x equals 5 minus 3x. Now, that's not written in the standard form. Normally, we see the 3x out in front. And that 3 to the x is a negative 3 to the x. You're going to keep the sign in front of it. That is a positive 5. So I'm going to change the order around. So this is the same thing as saying negative 3 to the x plus 5. So let's write it like that because we're used to seeing it that way. So y equals 3 to the x power. Table is going to be a little different. Negative 1, 0, and 1. 0 always goes with 1. 1 goes with our base, which is 3. Negative 1 goes with the reciprocal of the base, which is 1/3. Okay. Don't forget my horizontal asymptote. 0, 1, 1, 3, negative 1, 1/3. There we go. Now, this negative is not up in the exponent. It's not up in the exponent. So that is going to be on the outside. So this is going to be a vertical flip. When I say vertical flip, I mean each of these points are going to be flipping down. So my asymptote, they're actually just flipping over that. So the asymptote will still stay there. But my other points, whoops, I put that in the wrong spot. Sorry, should have been down a little bit more. But my other points now have all flipped. So now my exponential function is going down. And then just like on our minus 1 that we had on the last one, that plus 5 is also on the outside. So each of these things is going to shift up 5 spots. And there we go. Okay, so wanted to show you guys this one. You will see this probably on your homework there. If you see something where the 5's out in front, just move it to the back. Okay, not a big deal. Okay, 2 more practice ones here. F of x equals 4 times 1/2 x, or 1/2 to the x plus 3. Okay, starting out with y equals 1/2 to the x. Okay, some of you might be saying, why don't we move that 4? Whoops. Some of you might be saying, why don't we move that 4 to the back? We can't move that because the last one was a 5 minus 3 to the x. This is a 4 times, so I can't just change the order. Well, technically I can, but it's not going to help us at all to change the order, I guess I should say. Okay, so I'm going to make my table, negative 1, 0, and 1. 0 always goes with 1. 1 goes with 1/2. Negative 1 goes with the reciprocal, and the reciprocal of 1/2 would be 2. So 2, or negative 1, 2, 0, 1, 1, 1/2. Don't forget your horizontal asymptote. And there we go. Fraction just kind of makes it flip there. Okay. I would always start with the inside so that x plus 3 is on the inside. Again, we do the opposite. Everything is going to shift to the left. So y equals 1/2 x plus 3. So again, horizontal asymptote. Everything else shifting over 3 spots. Okay, good. Now, I've got this times 4. Remember, when I do something with a times 4, I want to make a table. Okay? Now, it's not the same table that I was making before. I'm going to make this table based on the previous graph. And I'm going to look at the x values of the previous graph. So I have an x value of negative 4, an x value of negative 3, and an x value of negative 2. And those are going to be the x values that I want to plug in. And I'm going to plug it into this whole thing right there. That's what I'm plugging it into. Okay? So, I'm going to have 4 times 1/2 to the negative 4 plus 3 power. Okay? So that's really a 4 times 1/2 to the negative 1 power. Now that negative 1 will make that fraction flip. So this becomes 4 times 2, which 4 times 2 is 8. So I'm going to have the point negative 4, 8 on this graph. So we're good there. Next one I'm going to plug in is negative 3. Negative 3 plus 3 gives me 0. 4 times 1/2 to the 0 power. Well, anything to the 0 power is just 1. And 4 times 1 gives me 4. So negative 3, 4 will be a point on that graph. And then the last one I have is negative 2. So I'm going to plug in a negative 2 plus 3. That's going to give me a positive 1. So 4 times 1/2 to the first power. Anything to the first power is just 1/2. And 4 times 1/2, or half of 4, would be 2. So negative 2, 2 is also a point. So this has caused this thing to stretch. And now our function looks like that. Okay? So that's an example of what a stretch can look like. Okay? Last one here has 4 shifts. I want you guys to pause the video, do these 4 shifts on your own. Okay? Start out with our table. X, Y, negative 1, 0, and 1. 0 always goes with 1. 1 goes with the base, which is 1/3. Negative 1 goes with the reciprocal. The reciprocal of 1/3 is 3. So negative 1, 3, 0, 1, 1 and 1/3. Don't forget my asymptote. There's our parent. Okay? I always do the inside first. So that negative x there, negatives cause a flip, and it's a horizontal flip. So asymptote pretty much stays the same. All these other points just flip. Okay, change horizontally. Shoot, I've got another negative. Where is this negative at? Well, this negative will be on the outside. So that's going to flip it down. So now all my points are all flipping down. Okay, and then that -1, there it is again. It's on the outside. It's going to just shift everything down just one spot. And there you go. And we'll work on these shifts when we get back to class.